So we're going to be looking at functions again today, and just as a reminder, a function is a relation between values where every input x has exactly one output y. The relationship between two quantities x and y is not always proportional. The relationship could be additive, meaning that one quantity y is a result of adding a value to the other quantity x. So before we were multiplying, and when we multiplied x, we got y. This was showing a proportional relationship. But now we're going to be talking about you add something to x to get y, and this is going to give us an additive relationship, which is not going to be proportional. So the additive relationships we'll be looking at can be represented using the equation y equals x plus b, and b means that's the y-intercept, or where the line crosses the y-axis. So y-intercept kind of sounds like y-intersect, and so you can kind of remember that wherever the line is intersecting the y-axis will be the y-intercept. So the y-intercept is shown using the coordinate 0, b, where b cannot be 0 on a graph. So that just means that additive relationships will not be proportional because their graphs won't cross through the origin, that point 0, 0, because we just said that that y value can't be equal to 0 for this to be an additive relationship. The y-intercept b can be positive or negative. If it's negative, our equation is just going to look like y equals x minus b rather than adding b there. So whatever your y-intercept is, we'll just plug it in for b, just like we did when we saw our slope was m. We would just put that value in where the m was. So same idea, but just a little bit of a different rule. So for an example, this problem tells us that Thomas is 4 years older than his sister Amanda. The following table shows the relationship between their ages at given points in time. So Amanda's age is 4, that means Thomas's age will be 8. He's 4 years older than her, so we just have to add 4 to her age to get his. So at any point in time, we just have to add 4 to her age, and that'll tell us what Thomas's age is. So this is an additive relationship because for every x value that you have to add 4 to it to get the y. So if we just call Amanda x and Thomas y, we can put these values in an xy table, and we can say that for 4 plus 4 we would get 8. 5 plus 4 we get 9, 6 plus 4 we get 10, and 11 plus 4 we get 15. Since we're adding 4 to every x value to get their y, that means that when x is 0, so when Amanda was 0 years old when she was just born, then y would be 4. Thomas would have been 4. So we can write that as 0, 4 in an ordered pair, and that's going to tell us that the y-intercept for this graph is 4, or that b equals 4. So since we know that b equals 4, we can use the equation y equals x plus b, plug in b as 4, and we'll get y equals x plus 4 as the equation for this relationship. So on the graph, rather than this graph starting at 0, 0, it's going to start at 0, 4. That means that when Amanda, which is our x value here, is 0, Thomas is 4, because he's 4 years older than her at any given time. When she's 1, he's 5. When she's 2, he's 6. So you just add 4 to her age, and that's going to get us their relationship. So this is additive because you're just adding 4 each time to x, and you're not multiplying x by anything. That's going to mean that the slope here is always just going to be 1 because we don't have a number in front of that x as our coefficient, so the slope is just 1. So as we get into actually writing the equation to represent the relationship, we're first going to look at what we can do if we're given a table. So the first step says to find the difference between y and x. Remember that difference means subtraction. So you want to start with your y and you want to subtract x from it. So for this first pair, we have 3, 12. The y is 12 and x is 3, so 12 minus 3. That means the difference is 9. Step 2 says if each pair x and y values have the same difference, then there's an additive relationship. So we only checked it for one pair, we have to check it for the rest. So the next y is 13 and the x is 4. 13 minus 4 is 9. Our last pair is 14 minus 5, and that again is 9. So yes, the difference of y and x every time here is the same. It's always 9, so this will be an additive relationship. So since we have an additive relationship, we can use the difference. That's going to be our y-intercept, and we're going to plug that number in for b in this general form of our equation. So the y-intercept here is going to be 0, 9, or you can write it as b equals 9. Those are two different ways to write it. And that's going to mean that our equation here is going to be y equals x plus 9. Now, if you want to just go ahead and try these ones on your own, you can. So you can pause the video and try them, or if you want to keep listening just to review, you can just listen to the explanation. So for the next problem, we're going to start over with our steps. First thing we have to do is find the difference between y and x. So my first y value is 5, and the x value with it is 9. So I'm going to do 5 minus 9, and that gets negative 4. We check the next difference. 8 minus 12 is negative 4. And in our last one, we have 10 minus 14, which is also negative 4. So our difference of y and x here is negative 4 every time. So we do have an additive relationship. That means we can say that 0, negative 4 is our y-intercept, or we can say b equals negative 4. So using our general form of the equation, we can say y equals x minus 4. Now if you wanted to, you could write it as x plus negative 4, but x plus negative 4 is just the same as x minus 4, so this is kind of a little bit more of a neat way to write it. And then you'll be able to identify what your y-intercept is very easily by seeing that there's a negative sign there, so we could say that the y-intercept is negative 4. Whichever way you prefer you can use, but I like this way best. In our next example, we'll start with doing our y minus x, so 0 is our y, we need to subtract negative 3 from that. Remember, when you subtract a negative, it's the same as adding. So really this just becomes 3. In our next one we have 3 minus 0, which is 3. And in our last pair we have 7 minus 4, which is 3. So the difference of y and x here is 3 every time. The y-intercept then is going to be 0, 3, or b equals 3. And that just means that y equals x plus 3. In our last example we have 5 minus 7 is our difference between y minus x, and that's going to get us negative 2. We have 8 minus 10, that's negative 2, and 10 minus 12, which is negative 2. So the difference of y and x is negative 2 each time, which means our y-intercept is 0, negative 2, or b equals negative 2. And we can write this in an equation as y equals x minus 2. Now the other way you can kind of see this is if you look at x and you see y, what do you have to do to this negative 3 to get 0? We just have to add 3. To get from 0 to 3, we have to add 3, and to get from 4 to 7, we have to add 3. So each of these x values here, when you add 3 to them, we're going to get their y value. Now for here, 7 minus 2 is going to get us 5. 10 minus 2 is going to get us 8, and 12 minus 2 is going to get us 10. So you can kind of see the pattern in the table just like that as well. Now as we go into our next example, this is telling us that we'll have to write an equation that represents an additive relationship from 2 points. First thing you want to do is find the difference between y and x, and then if each pair has the same difference, then we can say there's an additive relationship, and then the difference will be our y-intercept, and we can write it as y equals x plus b. So it says in the first example, a line passes through the points 2, 8, and 5, 11. What is the equation of the line? So one way that you could do this would be to write an x and y table of these values. So to do that, our first point would be 2, 8, and then our next one would be 5, 11. And then you can do what we did before where we had our table and we had to find the difference. So we would do 8 minus 2, which is 6, and 11 minus 5, which is 6. That would mean that b equals 6, or our y-intercept would be 0, 6, and that means that our equation is just y equals x plus 6. Now another way that you could do this, let's try it in the next one. We have a line that passes through the points 9, 4, and 10, 5. So what's the equation of the line? You can take your y values here and find your change in y. We can just say, we can say that x, to get from x to y here in this first point, to go from 9 to 4, what do you have to do? So to get from 9 to 4, we have to subtract 5. That's going to get us 4. To get from 10 to 5, think about what do you have to do to get from 10 to 5. 10 minus 5 would get us 5. So we can see that for each time we're going from x to y, we're just subtracting 5 from our x value. So that would mean that our y needs to be the same as x minus 5. So that's just another way you could do it if you want to look at it that way. I think the table is a little bit easier, and that's the way that we had learned it the first time. So if you like that best, I would stick with the table. So for this last one, we have x is -3, y is 6, and x is 4, and y is 13. So you find your differences. 6 minus -3, that's just the same as 6 plus 3, which is 9. And then 13 minus 4 gets us 9. So b would equal 9, or 0, 9 would be our y-intercept as a coordinate, and we would have y equals x plus 9. And you can see that for each x value you have, if you add 9 to it, you'll get your y value. So that's just one way you can test those out. Now in our last example for today, we're going to look at if we're given the rule, so the equation, we have to figure out if that point lies on that line. So we did this when we had some slope equations, and it's just going to be the same thing. We're going to use the x and y points and evaluate the equation for those x and y values. If both the sides are equal, then the point will be on the line. So in this first one, remember, we write our points as x, y. So I'm going to replace x in this rule, y equals x plus 5. X will be -4 and y will be -20. So using this rule, y equals x plus 5, we're going to say -20 equals -4 plus 5. And that's just replacing our x's and y's with those points given. So -20 will equal 1. Not a true statement. We know that those aren't equal values, so this point will not be on the line. In our next one, we have -2 should equal 3 plus 5. 3 plus 5 is 8, so this does not equal. So this won't be on our line. In our next example, we have 11 equals 6 plus 5. And 6 plus 5 is 11, so this is true. So 6, 11 will be on the line of y equals x plus 5. In our last example, it should be 4 equals -1 plus 5. And -1 plus 5 does get us 4, so this is true. And -1, 4 is a point on this line. So if you want to go ahead and pause the video and try the last two on your own, be good practice, and then when you're ready to check it, you can press play. Okay, hopefully you pause the video and try these on your own. So let's just go over these. All we have to do is remember plug in your x and your y to your new rule. So in our next one, we have y equals x minus 2. So my y here is 8, x is 6, and we have to subtract 2. So 8 is not equal to 4. This won't be a point on our line. In our next problem, we have 5 should be equal to 7 minus 2. And 7 minus 2 is 5, so this is true. This point will be on our line. In our next one, we have 18 should be equal to -9 minus 2. And -9 minus 2 is -11, so those are not equal values. That won't be on our line. And then we have 14 should be equal to 16 minus 2. And 14 does equal 14, so this one will be true and is a point on our line. In our last example, we have y equals x plus 7. So we plug in all of our values. 14 should equal 7 plus 7. 7 plus 7 is 14, so this is true. We have 13 should equal 6 plus 7. And 6 plus 7 is 13, so this is also true. 11 should equal -4 plus 7. And -4 plus 7 is 3, so this is not true. And -5 should equal -12 plus 7, and -5 equals -5, which is true. So this is a point on our line as well. So you just have to plug in your x and y values and evaluate it just as we did when we saw our slope rules. Thanks for watching.